All right, we are going to look at some weird cases where sometimes the derivatives don't exist and how that is related to the graph and finding its limits and all that good stuff. So what we're first of all going to do is we are going to create a piecewise graph right here. Okay, so in this first one, we are wanting to graph the equation 3 plus 1 half x. So that is a line where the y-intercept is 3 and the slope is 1/2. So I go up 1, right 2, up 1, right 2, or down 1, left 2. Okay. What's important to note is that line can only exist if my x values are less than 0. Okay. In fact, it can't even exist when my x value is exactly 0. So there's going to be a open circle right there, and it's going to go boom this way. Okay. Then in the next one, it says 3 minus x if x is greater than 0. So that means I have a y-intercept of 3, and my slope is -1 because it's -1x. So that line is going to go like this, and my x values have to be greater than 0. So that's the only part of that line that matters. Okay. The next thing it's asking me to do is to find the derivative at x equals 0. Remember, the derivative is the slope of the tangent line. Okay, well, when I'm discontinuous right here at x equals 0, and it's coming to a point at x equals 0, there's no definable slope, so my derivative can't exist. Okay, my derivative doesn't exist. Because there's no definable slope at 0. Okay. All right, now we're going to look at some points right here. And what this is asking me to do is to estimate what the derivative would be. Again, when you see this notation right here, it is the notation for the derivative. And the derivative is the slope of the tangent line. Okay, so if I'm looking at A, the tangent line would look something like this. And I do have a scale on this one, so it's a little bit easier to tell. But it looks like I may be going up 1/2 and right 1, and that maybe my slope is about 1/2. Okay, complete estimate, and that's all I'm asking you to do right here is estimate. At point B, since these two lines come to a point right there, it's called a cusp. And there is, oops, I didn't mean to erase that. There is no definable slope right there. Okay, and so the derivative actually doesn't exist at point B. So I'm just going to write DNE for doesn't exist, does not exist. Okay. Also at point C, because I can't approach point C from both sides. I can approach it from the right, but I can't approach it from the left. So here I'm approaching a y value, but I'm not approaching that same y value over here since it doesn't exist to the left. So since it's an end point, it does not exist either. Okay, then at point E, you have the same problem. As you approach it from the right and from the left, it's different. Oops, I skipped D. Okay, D looks like this would be the tangent line, and that is a horizontal line and has a slope of 0. Okay, F is another cusp that we've talked about when it comes to a point as it approaches. So that one does not exist either. G looks like it has a tangent line that goes something like this, and I'm completely estimating, but it looks like I go up 1 and right 3. So I would say that my slope is about 1/3. Okay, and then H, its tangent line would go something like that. And it looks like I'm maybe going down 1, 2, 3, and right 1, right 2. So about -3/2. Now, could you have estimated it totally different? Yeah, you could have. Okay, but something like that. All right, now what I'm going to have you do is I'm going to sketch a possible graph. And you need to know that there's lots and lots and lots of ways that we can do this. So we're just going to sketch one way, but we're going to graph. sketch a graph whose domain, first of all, goes from -3 to 6. So I'm just going to tell you that that means that your graph, and I'm just going to draw these in so that we don't have to sit and count every time, but your graph is kind of limited to between there and here. Okay, so it's limited to those things. All right. What this is telling me here is that my derivative at 0 is 1. So that means the slope of the tangent line at 0 is 1. Okay. The next thing, the derivative at 0.3 is 0. So that means that the slope of the tangent line at 3 is 0. So that means your tangent line has to be a horizontal line. The maximum point occurs at 3. So that's what I'm going to do. I'm going to first of all go to a maximum point of at 3. So this is the high point on my graph. I know that at the point 3, I have to have a horizontal tangent line. Okay, which means that my graph probably has to go something like that on either side of it, just so you know. Okay, then the other thing I know is the slope of the tangent line at 0 is 1, so that I know I have to have my tangent line here has to go something like that. So I am just going to estimate something like that, and I don't know, something like that is what that graph could look like. Okay, maybe clean it up a little bit. Now, could it have been 1,012 other things? You bet. Oops. I don't know what happened there. But that does qualify for everything that we needed to qualify for. So something like that. Okay. Excuse me. All right, next we have a graph whose domain goes between -5, excuse me, and 5. Okay, so I'm going to just draw kind of just some vertical dotted lines in there so that I know that that's kind of where my stopping points are. So here's where it's -5, and here's where it's +5. So I know my graph has to go somewhere between there and there. Okay, the derivative is 0 at x equals -2. So again, that means the slope of the tangent line, that's what that means, the slope of the tangent line at x equals -2 is 0. Okay, here the derivative at 0 is undefined. That means one of two things. That means it's either discontinuous at 0, or it means the tangent line is a vertical line at 0. However you want to make that look, the tangent line is a vertical line. Okay. The derivative is -1 at x equals 3. So that means that the slope of the tangent line at x equals 3 is -1. Okay, so we can certainly find a lot of things to make this happen, but it says that the minimum occurs at x equals 0, and we could do this lots of different ways, but I'm just going to say the minimum occurs at x equals 0. So I'm going to put some point down here. That's my minimum. Okay, I'm going to make it discontinuous at 0 also because of this little part right here. Okay, at 0 it's undefined, which means it's either discontinuous or the tangent line is a vertical line. I'm going to make it be discontinuous. Okay, the slope is 0 at x equals -2. So at x equals -2, it either needs to be a high point or a low point of something, and you can do it however you want. It doesn't really matter, but I'm going to go with something like this. Okay, slope of my tangent line at that point then would be 0, if you think about that. Okay, you can do lots of different things right there, but I'm going to do that, and I'm going to stop right there. And then my slope has to be -1 at x equals 3. So at x equals 3, my slope has to be -1. And that slope can kind of do anything you want, but at x equals 3, my slope has to be -1, which means I have to have something that goes something like that. So I am going to do this, and you can do many, many, many different things, but I'm going to go something like this. I'm going to go up and down and around, something like that. Okay, and that's what it would look like. Okay, now could yours look like something different? Absolutely. Okay, but that's one example. And that should do it.